Welcome back to Train Signal. This is Elias Knaser, and you're watching Clustering Hyper-V Hosts. I keep saying this, but I have another really cool lesson in stock for you guys. We are going to create the cluster out of the Hyper-V hosts that we've added in earlier lessons. This is another building block towards our private cloud. Now, if you've ever worked with Hyper-V clustering in the past, you'll find that it's been significantly simplified with VMM 2012. Now, a few things to note. When I say significantly simplified, in my opinion, it's still not as seamless as clustering with ESX, with vSphere, but it's come a long way from a simplification perspective, and you'll see in a second what I mean by that. It's also important to note, especially if you're going to be taking the test, that clustering is a function of Windows Server, not a function of VMM. That's really important. It's also important to note that clustering is not a requirement or a prerequisite for private cloud with Microsoft, for us to create that private cloud, but it most certainly is an enhancement, right? So the private cloud will take advantage of a lot of the clustering features and benefits. Now, the clustering features and benefits obviously include high availability and load balancing. High availability just in case one of the nodes, one of the hosts in the cluster fails, that VM or those VMs that are running on that host will find another home, another host to be able to be powered on and continue their service. Load balancing is when you're using live migration to essentially reload balance those hosts. So if you have one host with 2 VMs, another host with 10 VMs, maybe you want to rebalance them so there are 5 VMs here and 5 VMs there. Now, obviously that's not always necessarily the case, because you might have 2 VMs on host 1 that is consuming a lot of CPU and memory, and as a result it's a good balance. But in general, from a load balancing perspective, you're able to use live migrate, for instance, to rebalance the hosts so that they have equal workloads within the cluster. So there's a lot of benefits to clustering. So what I want to do now is let's go ahead and log on to our management PC and create our cluster. Okay, so I have the VMM management console up and running. There's one step that I want to do, one prerequisite before we actually create the cluster. So what I want you to do is come up here to the host group that we've just created, drag down to properties, and there I want you to go to storage. Now I've already done this, so you'll see that the storage disks are already showing up. For you, what I want you to do is click on allocate storage pools. And in your case, these storage LUNs or pools are going to be listed up here. So I want you to select one at a time, click on add, and bring them down here. Once you've done that, we are now ready to create the cluster. So to do that, we're going to click on Fabric down here. We're also going to click on Create, and then we're going to click Hyper-V Cluster. This is cool. So for me, I'm just going to call my cluster HV1, Hyper-V1. Doesn't really mean anything. It's just in case I have vSphere and Xen servers and stuff like that within other clusters, or maybe I have another cluster of Hyper-V, then it'll be Hyper-V2. It's just an easy way for me to identify what this cluster is. And from a run as account, we're just going to continue to use the Elias Knaser. Obviously in your environment it'll be something different. I'm going to click on next. From the host groups, we are going to select the servers that we want to add into our cluster. You'll see down here that there is a checkbox for skip cluster validation tests. So I wouldn't do that. The validation tests are very important. So what they'll do is they'll go through and validate the configuration and the settings of your cluster. So if they find any network inconsistencies, any storage inconsistencies, any features or functionality, any setting that you might have forgotten, anything that is required for this cluster to function properly, it will essentially throw an error or throw a warning at you that says, watch out, there's this particular feature or this setting that is not configured properly. Make sure that you are configuring it. So I would not skip the cluster validation test. It's going to validate the configuration of your cluster. And we'll take a look at this after the cluster is done configuration. So we're going to click on next here. And here this is also very cool. So our cluster is going to require an IP address. Now, you most certainly can come up here and just enter a manual IP address if you choose to do so. However, if you recall in an earlier lesson, we created that static IP pool. So instead of doing that, I'm just going to select that pool, or I'm going to enable it, and then I'm just going to select one of the IP addresses out of that static pool that we've created. Essentially, we've done it, so why not? This is more automation for us. Once you've done that, you can click on Next, and here you have the option of now configuring your disks. So you'll see that all of my disks are displayed or noted here. For the most part, you want to give each one of them, for instance, a volume label. So I know that this one is SSD, so I'm going to do that. I know that the 1 gig is my quorum disk, so I'm going to do quorum for that. And I know that the last one is SATA, so I'm going to do that as well. Now, from a partition style perspective, you have MBR or you have GPT. You have the option of selecting either or. I'm just going to leave them at defaults. From a file system perspective, again, NTFS is selected by default, and I'm going to stick with that. I want to quick format all of these disks, and towards the end here you have the option of creating a cluster shared volumes. Now, what is a cluster shared volume? What is a CSV? NTFS on its own is not a clustered file system, which means only one host can have access to that file system at any given time. When you enable CSV, you are layering on top of NTFS the ability to have multiple hosts connect into that volume, and that's essential, especially if you're going to be hosting virtual machines on these volumes, right, on these file systems. So without NTFS, things like live migration wouldn't work unless you're migrating or you're live migrating the entire LUN. However, when you do CSV, well, now you can take a single virtual machine and migrate it and live migrate it. So very, very helpful if you're going to have virtual machines live on these file systems. Again, it's an overlay on top of NTFS that extends its capabilities for clustering purposes. So what I want to do is I want to select one of them, the SATA drive, for clustering purposes for now, and I'm going to leave the other ones without this selection for now at least. And by the way, the cluster is automatically going to recognize, or it's going to use the volume or the disk with the smallest disk size as the quorum. So even if you hadn't selected that, or even if you haven't done anything, it's going to detect that, hey, I have 3 disks here, 3 volumes. The smallest size is the one that's going to be used for the quorum. So we've done our homework properly. We've prepared that, so it's going to detect that, okay, these guys are smart guys. I'm gonna use this particular disk. We're gonna click on Next to continue here. We've done our homework from a networking perspective, and we've done all the configurations necessary. So VMM doesn't have to do anything for us. So there's nothing here to display or configure from a logical networks perspective. We've already done all the work for that. So I'm just going to skip this step, and this is the summary. Once you're ready, we're going to click on Finish and watch this thing go. Let's see down here, we're going to bring up the jobs window, and this will take a few minutes here for the cluster to configure properly. Alright, so the cluster has completed. Now, while it was successful, there's a few warnings here. Now, this is one of the things that I absolutely love about VMM, is all of these provisions that they have created within the system that would guide you through, well, what's going on, right? So we know that we have a successful cluster creation, but we have some warnings. So what does that mean? Let's take a look. We're going to go out and exit out of the jobs here. You'll notice that immediately I now have the new cluster, which is called HV1. So if I select that, right click, and we drag down to properties, under status here, you'll notice you get some information about the status of this cluster. So we know that the cluster is successful, but some warnings, and it'll show you the report. So if you click on this link, this is a report that's coming off of Hyper-V 01. If I click on it, it's going to essentially open up a web page. You have a very cool summary here of what's going on, what the warnings were, and it gives you a lot of information. I mean, look at this. It's just tons of information on what you've got within your environment. Let's take a look at what the warning is from a networking perspective. So if I click on network here, it'll again bring you down to 2 summary screens from a network perspective, what's going on, right? So you have the validation, there's an IP configuration problem. If I click on it, and you can take a look at all of your configuration across all of your hosts, but if you keep scrolling, you'll get to a point where it's giving you what the problem is essentially. So in my case, the problem is that my management interface and my virtual machine interface or virtual switch happen to be on the same subnet. Well, and VMM recommends that maybe you should VLAN off your management network so that it's dedicated on its own network. Oops, not a big problem. Nothing that is a showstopper. Best practice, again, you should probably do it. For the purposes of my demonstration, this is enough. Now, if we go back and we take a look at what we have from a storage problem here. So the other warning was under storage. So if I click on storage, it'll bring me to this whole summarized screen. And again, based on the warning, I have a validation of the Microsoft multipath input output. So let's click on it and see what's happening. So what it's telling me here is that basically I have hosts 1 and 2 that don't have redundancy from a path perspective to the disk. There's only one path going to the disk, and that can be a single point of failure. So what I should be doing is looking at Hyper-V 1, Hyper-V 3 in this case. Those are the two that are showing the issues, and figure out why multipathing isn't working to my disks. Again, it's not a showstopper from a cluster perspective, but these are warning, hey, be careful, this could be a single point of failure and it could cause you issues down the line, so make sure you address them. So let's get out of this report. And by the way, this report exists on every one of your Hyper-V servers. So in order for you to get access to that report, it's actually %windir %cluster / cluster / reports, and you'll be able to get to this particular report here. So you can substitute this entire line here with %windir on any one of your Hyper-V servers. Then you do cluster reports, and it will show up. The entire list will show up. Now, while we're in here, before we continue on with some of the few things that I want to show you, in case you're having problems with the cluster creation at home, in case you're following along and you come across some errors, here's a few things that I want you to look at. Let me switch over to Hyper-V 1 and show you a few things. I want you to open the server manager down here, and then once it's open, browse to File and Storage Services, Volumes and Disks, and you should be able to see something that resembles this. Now, if your cluster was unsuccessful, those disks are going to be all over the place. Well, first of all, what I want you to do is from Hyper-V 1, Hyper-V 2, and Hyper-V 3, make sure that you're able to see all of the disks. All of them should be visible from each server. Once they're visible from each server, before your cluster can be successful, all 3 of your disks should be offline. If they're not offline, if they're in different states, then what you want to do is right-click on them. If you can bring them online first. Once they come online, I want you to reset the disk. Once the disk is reset, then take it offline. Repeat this exercise for all 3 of your disks. Hit F5 to refresh, and all of your disks should essentially be offline, and this should be unknown. Your partition here should be unknown across all of your hosts. Once this is ready, you'll know that, okay, from a disk's perspective, I can see all the disks, I can see them on all the hosts, all the other hosts can see the disks, they're all offline, you've reset the disks, those are ready to go. This is what it looks like when the cluster is successful. Remember when we were going through the wizard essentially we chose MBR from a partition perspective. We chose clustered for some of them, so we've made some of them clustered. So it's done all the right things for me. That's one, right? So this is the first thing that I want you to take a look at. If you're having problems seeing the disks, then I want you to go back into administrative tools here. I want you to come back to iSCSI Initiator and make sure that all of these disks are connected. Make sure you're selecting each disk, you're going through connect, and you're configuring your multipathing properly. That's from a storage perspective. From a networking perspective, if while you're viewing the report, or if you're in the event or the jobs window and it's showing you that there's some issues from a network perspective, then I want you to visit each one of your hosts, click on Hyper-V Manager, and you need to double check a few things. So click on your virtual switch manager, click on the VM network here. Make sure that the label on all 3 of your Hyper-V hosts is the same, and I mean it matches. Uppercase, spacing, everything has to match. Remember when we were talking in earlier lessons about the fact that VMM is automatically going to match the networking that's on your Hyper-V hosts with logical networks on VMM, and this is one of the ways it's matching it. So if this is not matching, it's going to throw a lot of errors from within VMM. So make sure these are configured properly, and then try to run your cluster again to be able to get it to a successful, or at least a warning state, success with warning, like what I showed you earlier on. All right, back on our VMM management console here. We're still in the cluster properties. Let's go through general here. Let's start at the beginning. This is essentially going to give you a general overview of what's happening in your cluster, the name, the host group, if you want to give it any kind of a description. And then down here, you see that you have cluster reservation nodes 1. Then you have cluster reservation or reserve state is okay. And you have cluster reservation details if there was any details of each other. So what does this mean? What does cluster reserve by nodes mean? Well, when you're creating a cluster, the whole idea of a cluster is that if you lose a single host, or if you lose more than one host, the remaining hosts in the cluster have enough capacity, have enough resources to be able to power on the VMs from that failed host. What we're doing here is we're telling our cluster, we're configuring our cluster to say we are willing to sustain one node failure. So I have a cluster of three nodes, and if one fails, then I've configured the other two. I've over provisioned them from a hardware perspective, from a CPU, from a memory, from a disk perspective, to take on the load of that single host failure. If I have more than one host failure, then you have a problem, obviously. So your job as the admin, as the architect, as the engineer, as you're speccing out the hardware to figure out, well, what are you willing to accept from a failure perspective within your cluster, and then to make sure that you have enough resources in the others to take on that load. So two things have to come into account here. First of all, you have to make sure that your hardware, you have enough hardware. But number two, you want to make sure you're not over provisioning your cluster. You're not over provisioning these hosts. So if you have 128 gig of memory in one of your hosts, or in all of your hosts, that doesn't mean that you get to 120 gig of memory on all of them, because that means if one of them fails, the remainder hosts are not going to be able to take on 64 gig of memory each, or 60 gig of memory each. So understand how many VMs you're going to have to put on each host, taking into account if a single host fails, you want to absorb those VMs, and then you'll be able to figure out what you're doing from a cluster reserve perspective here. Now, if we come down here to available storage is also very interesting. If you've ever worked with vSphere, again, if you've ever worked with vSphere and you're going out and adding storage, well, it's going to show you all the available storage that has not been provisioned yet. Well, this is kind of similar, right? So this is showing you the available storage that you can convert to CSV, or you can add storage so that it becomes available storage. So either here, this is available storage that you can convert to cluster shared volumes, or you can add additional storage to this cluster. Now, if I choose, for instance, on my SSD here, I want to host virtual machines on this, and I want to be able to do live migrate and other things, well, I'm going to turn this into CSV. So I'm just going to click on it, and you see how quickly that executes. Now, once you've done that, in order to see what you've created, you're going to come down here to shared volumes. And under shared volumes, you'll be able to see those cluster shared volumes that you've created. And you'll notice that CSV completes very quickly. And the reason it completes very quickly is because it's an overlay for NTFS. It's not, formatting anything all over again or doing anything crazy. It's simply overlaying on top of NTFS. Now, conversely, you can take any one of these volumes, essentially, and convert it back to available storage. Now, you'll notice that I skipped here over file share storage. File shared storage is, again, a way for you to add storage in the form of a file share, like a G drive, like a UNC or an SMB path, which you can then make available to those VMs that you're deploying to this cluster. So again, a different way of provisioning storage into your cluster. Now, from a virtual switches perspective, you have we've already added our VM network for Wired Brain Coffee. That's the one that we've created earlier. It's automatically been assigned into this cluster. From a migration settings perspective here, you have a whole slew of things for you to consider. For instance, the maximum number of simultaneous live storage migrations that you want to accept within this cluster. Live migration settings, again, a whole slew of settings here. Again, maximum number of simultaneous live migrations. So live migrations are obviously different than live storage migrations. By default, you have two. The type of authentication that you want to use, you can use Kerberos, or you can just keep it at the default. Again, you have the incoming migration network settings. If you want to receive the live migrations are going to be performed on a particular network, then again you can select which one you want here. You can add it, you can keep it at the default, whatever you need to do. Then from a custom properties perspective, you have the options here of adding a lot of custom properties, and these are going to become relevant as we start building more into our private cloud. But you have the option here again of specifying specific attributes. So for instance, if you come to host here, you're able to create different types of attributes and classes that you can then apply certain automation and orchestration tasks against. For now, we're going to keep this blank. We're going to cancel out of here. And I'm also going to cancel out of here. Yes. And there's a few more things I want to show you. So in earlier lessons, when we were talking about the host group prod that we created, we skipped over a few things. And those were, for instance, the placement rules here. So if I click on placement rules, you have the option of specifying certain rules for virtual machines. Now, what do those rules mean? Well, those deal with affinity and anti-affinity rules. This is very similar again to what you would see in vSphere. So those of you that are familiar with vSphere, you're probably familiar with this concept as well. What this means is if you want to have certain virtual machines to always exist on the same Hyper-V host, then you can create a rule for that. If you want certain virtual machines to never exist on the same Hyper-V host, you can also create a rule for that. So for instance, if you have a couple of domain controllers, well, if those domain controllers as part of placement or live migration or rebalancing of those nodes happen to exist on the same Hyper-V host, well, that's a single point of failure. You want to make sure, for instance, your domain controllers never exist on the same Hyper-V host at the same time. So you create a rule for that. If you're dealing with Citrix XenApp servers, you might not want to have certain XenApp servers exist on certain hosts for whatever reason, or you might want them to exist. Now, in a private cloud scenario, we're going to start talking a little bit later on about the concept of services. Services is when you are aggregating several virtual machines and managing them as a single entity, right? So sometimes those services, you'd want them to always be on the same host for performance reasons, and sometimes you'd want them on different hosts, again, maybe for performance reasons. So these types of placement rules will deal with where that virtual machine is going to be at any given time and how it's placed there. For now, we're not going to deal with that, so I'm just going to leave it at defaults. But let's now move to host reserves. Host reserves deal with the amount of resources that are essentially set aside for the operating system, so the parent operating system. So in this case, it's Windows, right? So Hyper-V sits atop of Windows. If the actual Windows operating system is hungry for resources, is starving for resources, then it goes without saying that the virtual machines that are living on top of that operating system aren't going to perform properly. Now, by default, there are some resources set aside. If you want to override that, you can uncheck the box here and maybe increase the CPU, increase the memory, the disk space, whatever, disk I/O, disk space, whatever it is, to ensure that the operating system, the parent operating system, isn't being starved for resources, and as a result, it's not becoming a bottleneck for the rest of the virtual machines that are running on it. That's very important. From a dynamic optimization perspective, again, this is very similar to what you would find with vSphere from a DRS perspective, and how DRS is load balancing the different nodes within the cluster. So you have essentially the same thing here. How often do you want me to rebalance the cluster? And by rebalancing the cluster, it's the same concept that we talked about a second ago. We have 3 hosts within our cluster, and these hosts have virtual machines running on them. Every so often, dynamic optimization is going to run a check and say, okay, well, this host has 10 VMs, the other one has 2, and the other one has 3. I'm going to take a few VMs from this host that has 10 and spread them across the other hosts so that I have equal workloads across all of the hosts. Now, it can run this check very aggressively high, which means it's going to balance even for small gains. And what that means is if it runs a check and finds that, Hyper-V 1 has 10% CPU utilization, Hyper-V 2 has 12% CPU utilization, and it knows that if it moves one VM from Hyper-V 1 to Hyper-V 2, it might get them to 11% CPU utilization, it's going to do that. That is very aggressive. That's going to take up a lot of network bandwidth. It's going to put a lot of stress and resources. It's going to be resource intensive on your cluster. I wouldn't recommend it. Then you can go down a little bit from medium. And the setting that I really like to use is low, which means load. I want you to load balance when there is substantial gains out of doing that. That does the live migration and does the auto rebalancing only when it's absolutely necessary and when I'm going to get the highest level of gains. So you can override here the host group settings and then essentially just take it up or down a notch, however way you find fit here. Now by default, it's going to automatically run a check to reload to load balance your cluster every 10 minutes. If you find that this is not enough, this is slow, or this is too fast, then you can obviously select this and tweak the setting here based on what you see fit. I'm going to leave those at defaults for now, but down here you'll also find that you have the option of optimizing when hosts are being calibrated depending on their available resources. So do you want to calibrate maybe when the CPU hits 30%? Well, maybe the memory should hit 512. So you're able to tweak here those resources and when that optimization should occur. Now you also have power optimization down here. Power optimization is really cool. And again, this is a feature for those of you that come from vSphere that is also available with vSphere. So what power optimization will do is if you have a lot of hosts, and this is perfect, for instance, in a VDI environment. In a VDI environment, we have hundreds and hundreds of virtual machines. Except these virtual machines are typically used between work hours, right? So let's say from 6 a.m. in the morning to 6 a.m. in the afternoon. That's kind of the time that they're going to use this. But from 6 p.m. to let's say 6 a.m. the next morning, these VDI VMs are going to sit there idle. So what you can do from a power optimization perspective is you can compress the amount of virtual machines that are running on your Hyper-V host. So let's say you specify a certain time here that says between these times, if you're able to compress the largest amount of VMs on a particular number of hosts, then you're going to end up with hosts with no VMs running on them, right? So you're compressing them down to the fewest number of hosts. Well, what you can do with the hosts that are empty is you can power them off. So that way you're saving on power, on cooling, on a whole slew of things within your data center, and that translates into money. So what you do is when you're powering these hosts off, you're powering them off for a certain period of time, and then before your day starts, before you know that you're going to get, loads going to build up again, then those hosts are powered up again and your cluster is rebalanced across all the available hosts. So power management, very useful. Take a look at it and see if that is of use to you. We're going to click on cancel here, and then I showed you here from a networking perspective what it's doing. We have, this is what we configured when we created our cluster, and this is the IP address that essentially it took. And then from a custom properties perspective, it's the same thing as the host group custom properties. We'll be looking at that a little bit later on. This is the storage that we provisioned also, that I showed you how to do that earlier on. I'm not actually going to click on anything. I just want to show you guys the properties here. So I'm going to go ahead and click on cancel now. And at this point, what I want to do is I want to show you how you can add a VMware ESX server, a VMware vCenter server to your VMM. So to do that, let's take a look at some of the requirements. So in order for you to add any kind of ESX or ESXi host into VMM, you have to first add VMware vCenter. So VMM is going to manage these hosts via vCenter. So what happens is the vCenter servers that are supported are VMware vCenter 4.1 and 5.1. Your ESX hosts that are supported are ESX 4.1, ESXi 4.1. You remember, ESX and ESXi are different. ESX had a service console, ESXi did not, and it was at the point of the 5.0 release where the ESX version with the service console completely goes away. So ESX 4.1, ESXi 4.1, ESXi 5.1 are supported. VMware hosts or clusters must be managed by vCenter again. So you cannot add the host directly. It has to be managed by vCenter, and vCenter in turn will be managed by VMM. So the first thing we're going to do is we're going to add a vCenter server, and then we're going to add an ESX host. So let's take a look. So under Fabric here, you'll notice that under servers, I have a node called vCenter servers. What I'm going to do with vCenter servers is we're going to right click on it, and we are going to click on add VMware vCenter server. And then I'm going to simply add the IP address of this server, which in my case is 192.168.1.13. My run as account is Elias Knesser. Again, this has rights over that vCenter server. I do not want to communicate over any kind of certificates or secure mode. Again, in your environment, you probably want to have that enabled. If you don't, then it's just going to prompt you as it would if you were logging directly into an ESX host server. So once this is ready, I'm going to go ahead and click on OK here. It's prompting me to install the vCenter SSL certificate. I'm going to import that. There you go. We're going to exit out of jobs here, and voila. It has imported my vCenter server. Well, now that my vCenter server has been imported, I can now import ESX hosts. So I'm not going to create any new host group for ESX. So what I'm going to do is I'm going to just import it under all hosts here. So if I right click on it and I drag down to add VMware ESX hosts, I have the option of first setting a run as account. Now keep in mind, the run as account that you select here must have access onto that ESX host. So it needs to have root access. So what I've done is if you click on browse, you'll notice that I have a hypervisor admin account that I've created. This essentially just has the root and password of the ESX host itself. So if I select this, and what I've done, I've called it hypervisor admin because in a second we're going to add a Zen server. And I've standardized my root username and password for all of my hosts. So whether it's ESX or Zen server, they are using the same root username and the same root password. As a result, when I'm creating a hypervisor admin, I can use it across both. So I'm going to click on OK here, click on Next, and you'll see it's essentially showing me all of the different ESX hosts that I have under my vCenter server. I'm going to take this particular one, and let's go ahead and click on Next. I want to add it in the All Hosts group here. Click on Next and click on Finish. Pretty cool, right? Let's go ahead and click out of here. And you'll see that I now have an ESX host in my environment. I had it in my vCenter as an IP address. Shame on me. Do not do that. Make sure it's in there as the fully qualified domain name for a whole slew of reasons. But this is my ESX host that we've just imported. What do you guys say we take a look at the requirements for Zen server? Zen server is supported via version 6.0 and 6.1. You will need the Citrix Zen server Microsoft System Center integration pack. Now to download that, you're going to have to go to My Citrix, so citrix.com/mycitrix. Log in, go to the downloads section for Zen server. Under Zen server, under its components, you'll find that there's a package called Microsoft System Center integration pack. You're going to want to download that integration pack, and then you're going to follow the steps that I have listed out on the screen here for you. What I want you to do first is during the installation of Zen server, I want you to give it a fully qualified domain name. So for instance, zenserver01.wiredbraincoffee.com. Give it the full domain name so that the SSL certificate that gets created with the fully qualified domain name. You can change it later and reissue the certificate. It's just a hassle, it's a headache, so make sure you've done that first. Download the ISO from My Citrix that we just talked about, the System Center integration pack for Zen server. Download that. Mount the ISO. So depending on what you're using, if you're using VMware Workstation or ESX or whatever you're using to essentially create Zen server, or maybe you're just using a physical server, in that case just put your CD in the CD-ROM, or use whatever method you need to mount your ISO. Log into your Zen server, essentially to the console of Zen server. The last option down there is to be able to get command line access to Zen server. Once you get command line access to Zen server, I want you to create mkdir, which stands for make directory, space dash p space forward slash mnt forward slash tmp. So mount temp. And then once you have that, once that directory is created, I want you to type mount slash dev slash DVD, which means you are mounting the actual DVD, the physical DVD, and I want you to mount it into the directory forward slash mount forward slash temp. If you didn't put the actual physical DVD or mount the ISO, and you've copied that ISO to your Zen server onto a location, then your command would be mount the path to that ISO, whatever it is, and then forward slash, the ISO name, and I just abbreviate it to xs.iso, but it could be something longer. And then you're mounting it into forward slash mnt tmp-o space loop. Once that's done, either way that you've done it, I want you to do a cd forward slash mount forward slash tmp, and you can do an ls to see the contents of that directory, but essentially I want you to issue the command dot forward slash install dot sh, which is going to start the installation of the integration pack. I'm going to assume that you've done that and that's gone successfully. Let me show you how you would add a Zen server into VMM. We're going to essentially do the same thing. We're going to add it onto the old host. So I'm just going to right click and we're going to come here to where it says add Citrix Zen server. And here what I want to do is I'm actually going to enter the name Zen server 01.wiredbraincoffee.com. I do not want to communicate over SSL, which is going to take a little longer for this to work, but I'm going to leave it as is for now. The run as account is going to be the hypervisor admin that I had created earlier on, and then I'm just going to click on add. And there it is. I'm going to select it, and once that's selected, I'm going to select this option down here that these certificates have been reviewed and can be imported into the Trusted Certificate Store. So that's all cool. We're going to click on Next, and we are going to click on Finish. Let's get out of the Jobs window here. And there it is. After a few seconds, it will show up, and voila. Now, why do you need multiple hypervisors within a private cloud? Why not all Hyper-V or all Zen Server or all ESX? Well, there's several reasons. Sometimes certain workloads are going to work better on one hypervisor over another. Sometimes you might find that from a cost perspective, you want to use one hypervisor over another, but it's very expensive, so you're going to leave that hypervisor for the workloads that are ideal for that hypervisor, whereas you want to provision other workloads for a different type of hypervisor. Having that flexibility in a private cloud is crucial. You want to be able to have any kind of hypervisor that you want for the different type of workloads. For example, maybe running databases or workloads that require intensive disk I/O, and I'm just saying maybe for example's sake here, maybe those are better for ESX. So you have that, you keep that for your high dollar workloads. Maybe you have a VDI environment that you want to use, for example, Zen Server with. Well, you keep Zen Server around for that type of workload. Maybe Hyper-V is going to be your general hypervisor of choice for everything else. Well, then you have the flexibility of having all three of them, and you have the option and the flexibility again of managing them all from the same interface inside of the same private cloud, whereas you're placing workloads where they need to be. So multiple hypervisor capabilities is very important in a private cloud, and with Microsoft VMM 2012 ServSpec 1, you have that capability. So let's recap what we've learned in this lesson. We talked about Microsoft clustering, or about Hyper-V clustering, about the fact that clustering is not a prerequisite for building a Microsoft private cloud, but the Microsoft private cloud will take advantage of clustering features like high availability and load balancing. We also talked about the fact that clustering is a function of Hyper-V, not a function of VMM, and that's important. We then went through and we configured the cluster. We added all of the hosts that we wanted into the cluster. We got a warning, and I showed you what that warning meant, and I also gave you some tips on if you're having some trouble configuring your cluster, what you should be looking at. Then we took a look at how we add a vCenter server into our VMM, and the fact that in order for you to add any kind of an ESX or ESXi host into VMM, you have to first add a vCenter server because VMM is managing those hosts through vCenter. So we added vCenter, and then we added an ESX host, and then I showed you what it takes also to install or to get XenServer into VMM, and the fact that you have to install the System Center integration pack for XenServer first on XenServer before you can integrate it, and then we added a XenServer host to VMM. At this point, to be honest, I mean, we can always click that create cloud button, but I'm going to leave that for another lesson or two before we get into some of the cool things. But I hope this lesson was very informative for you, and I'd like to thank you for viewing.